First, we gave the students directions as to how to complete the experiment.
Our topic was energy, and we thought it would be important to give you the definition of energy so you kind of know what you're looking for. It's power that may be transferred and changed from one form to another. And there are a couple different types: thermal, electrical, mechanical, radiant, and kinetic. And the complex question that we wanted to propose was, how would heat energy transfer?
Your materials are, there are lights set up around the room. We have an industrial light, the flashlight, heat lamp, as well as two other lamps over there. Your other materials are bottles that are painted white and black, and you have a variety of balloons. So please feel free to begin your investigation. I'll be handing out a piece of paper to help your group, so you can either fill it out individually or as a group, however you
A little
like.
different than the other groups, so we're not going to do the posters. We wanted to collect the your
Material.
guys' inquiries and that kind of sort of thing. So we have worksheets that we print out, and they're front and back. You're going to fill the one side out before, the other side after you conduct your investigation, okay?
Next, we had the students go around the classroom to places where we had the experiment set up and had them conduct their investigations based on their own inquiries.
See if anything happens. Oops.
Oh, jeez.
Sorry. Watch, it just like blows up. It pops in my hand.
Oh, God.
I want to see if like anything is happening.
I know. Oh, look at that.
It looks like something's happening. Unless it's just like really stretched out, but this one isn't doing that yet. Right? Doesn't it look like something's happening there?
It smells bad.
Is it?
Farther away.
So do this investigation. Because the first thing with this setting that everybody goes with is this.
Yeah.
Can you have more ideas?
We gave each student a worksheet which we had printed out previously. On one side, they needed to list their claim, their evidence. They needed to draw a picture of what they thought would happen. After they had conducted their investigation, they would need to answer their group's why question, what is their next inquiry based on their first investigation, and what conclusion it led them to. Also, for our own information, we wanted to understand how well they understood energy after we had taught them the lesson. So this is a personal survey that we could reflect on to see how we could better our experiment if the next time we do it. After the students had conducted their investigations, we met back as a group and went over what they had found. Each group shared, and we wrote on the board each of their inquiries. On the worksheet, from what we saw, a lot of the students had done a very good job depicting the transfer of energy. And as far as we could tell, most of the students got a fairly good understanding, or at least better than they started with, of energy. When we conduct this experiment later, we hope to improve their understanding even more.
Testable questions you have that were associated with the complex question?
We started with determining what bottle, black or white, would blow up the balloon quicker, and we found that the black one did. And then we tested the distance. So we just kept the black bottles and we put one closer and one farther, and the closest one blew up the balloon faster. And it took an additional 89 seconds for the second one to blow fully up.
Okay. So you guys did distance, which was different than anything that we tested. So that's pretty interesting. Very good.
We just kept the bottle and balloon for each lamp close to the same distance, roughly.
Right next to each other, we had a white bottle and a black bottle. And we found that the black one usually blew up I mean, all the way blew up more quickly. It blew up at all. So the
Did you
distance
test
was
the-
very interesting.
That's what
Did
we
you test
started.
the white bottle along with that black ones? With that lamp?
With the distance, did you test
For
what
the
about
first
it?
one we did.
Okay.
And then once we realized the black was gonna win,
Right.
then we did both black.
Because that lamp and the other one are the only ones that blew up the white.
Well, I break over there, which is interesting.
Oh yeah, the little one over there too.
The white one did, it took longer.
Right.
Okay.
So the question is why? Why the distance matter?
Can we talk about that after because all the
Oh,
Yeah.
sure,
it is
We're gonna have-
similar.
sure.
So you guys want to share?
Yeah, we wanted to see what either the white or between the white and the black, which balloon would fill up faster. And we picked a light and we held it, we noticed that other people held it on the side, but we held it on the bottom. And just like you guys said, we found that the black bottle heated up in, which one's which?
Black was 15 seconds.
And the white was a minute.
Which lamp did you guys use?
The white one.
The white one.
I found that interesting too because when we were doing this, we could not get any of them to blow up any balloon except for the heat lamp and an industrial lamp. But when you guys did the bottom, it was interesting
Yeah,
that
we didn't
worked.
even think to do the side.
Do you guys have any why you think that might have been?
I didn't even know, because I didn't even realize that that wasn't what everyone else was doing until I looked over and everyone else, like,
Yeah.
the bottles were there.
I would think it was. Yeah, we always did on the side, but the more I'm thinking about it,
It was going
Yeah.
up.
Yeah.
it's a surface area thing. The
Right.
heat is focused to a larger surface area for the side, whereas at the bottom, it's just a smaller surface area, so the heat can radiate upward instead of trying to radiate across the whole bottle.
Yeah, that
Yeah.
makes sense.
I thought that was really interesting.
Did you keep the distance the same?
Yes.
Yeah. Did you guys do the white one also?
Like with the side and the
Yeah,
bottom?
the white took longer, but they both blew
They
up all
both
the way.
blew up.
With that small white lamp.
Yeah.
Did you time it or no?
Yeah.
Yeah, it was 15 seconds for the black bottle and a minute for the white one.
No, when you compare the side with the bottom, did you keep this?
We didn't do the
distance?
side at all.
We
We
didn't
just
realize.
used the light on the bottom.
But we're comparing it to when we did
Oh.
this side in our experiment, which we couldn't get it to blow up at all.
Oh, okay.
So I mean, I guess it's comparable, it's just two different experiments, but we couldn't get it to blow up at all, but they did from using the bottom. So pretty interesting. Okay.
So an investigation that coming out of this would be, what if I have two bottles, same, everything the same, one of them is on the side, one of them from the bottom, facing the light. Then what would happen? If we keep everything the same. So a new question can come out of our investigation.
You guys group want to share?
We were testing like the light bulbs, our claim was the stronger wattage of the bulb, the faster the balloon would blow up.
Okay.
And that was true, because the 40 watt, nothing happened. 60 we got it too, because we did the bottom like they did. The heat lamp, it blew up fast, flashlight, nothing, and then the industrial lamp, it blew up too.
Do you guys do the black and the white or just the white? So they only, the black one only blew up on the two strongest ones or which ones?
All of them, the
white one did?
and white did too.
Blew on all four?
Well, just on the 60 heat lamp and then industrial.
So you guys want to do with the heat source more?
Yeah, so the stronger the watt,
Okay.
the faster the balloon blew out.
Did you do the same? Did you